Good morning, students. Now we have started with the electrochemistry chapter. So, today we are going to see measurement of conductivity. In that we have seen conductivity cell. So, what is conductivity cell? Conductivity cell consists of glass tube in which two platinum electrodes are there, which are coated with the platinum black, finely divided, and then that is dipped into a solution of chloroplatinic acid, and this is a conductivity cell. Now, when you want to find out potential of any of the other what we can say electrolyte, so that time we will dip this conductivity cell into a solution and we will find out its EMF. Now, cell constant. So, okay, cell constant also we have seen the conductivity of an electrolytic solution is given by the formula. This you are aware, that is conductivity of a electrolytic solution is 1 upon R L upon A, where R is about electrical resistance. Now, what is L here? L is a ratio of separation between the two electrodes, which are divided by the area of cross sections of an electrode. So L is what? Ratio of separation of two electrodes, and A is the area of cross section of an electrode. This is called as a cell constant. So cell constant is what? L upon A. Now we will replace this L upon A and we'll write their cell constant. So conductivity is equal to cell constant divided by R. Determination of conductivity consists of 3 steps. So let's see how conductivity of any unknown cell is we can measure. Determination of cell constant. So first we have to determine the cell constant. Now the cell constant is determined using a solution with a different concentration. Suppose here we will take the potassium chloride solution. One is of a 1 molar, other one is of a 0.1 molar or 0.01 molar. So with a different concentration, we are determining the cell constant. Conductivity of a potassium chloride solution is well tabulated at the various temperatures. So depending upon the temperature, at what temperature a particular what we can say electrolyte shows us release of a dissociation of that electrolyte. It depends upon the temperature. If temperature is high, the dissociation rate will be high. If the temperature is low, ions won't dissociate very easily. The resistance of potassium chloride solution is measured by the Wheatstone bridge. So in order to measure the resistance, what kind of apparatus is used? Wheatstone bridge. This you have studied in physics and in chapter 9 of this 12th physics textbook. If you'll see, there is a information about the Wheatstone bridge is given. So what is this Wheatstone bridge? You can see in the figure 5.3. AB in the Wheatstone bridge is an uniform wire, okay, where Rx is a variable known resistance. So this is a variable, but it is known resistance, which is placed in one arm, means one side of the Wheatstone bridge. So here is A to B is a uniform wire, whereas one hand or one side, so our variable resistance is present on the our right hand side, okay, and on the left hand side, on the other side of the Wheatstone bridge, conductivity cell is there. So this conductivity cell we have studied, that conductivity cell is placed on the which side? Left hand side of the, and solution whose conductivity we want to find out, that solution we will place in this conductivity cell. Okay, so solution of an unknown resistance is taken, whose conductivity resistance we are not knowing, that we have used. We will place this conductivity cell in the conductivity this apparatus, and then we will measure the resistance. The conductivity cell containing potassium chloride. Now, if it is containing potassium chloride solution, so the solution which we want to measure is a potassium chloride of an unknown resistance. We don't know its resistance. We have placed in the one other arm of a Wheatstone bridge. D is a current detector. You can see here D. D is a current detector and there is a jockey is attached. So where the deflection is there, we have to see and we have to move the jockey till we'll get a zero deflection. So D is a current detector. F is a sliding contact. So this is a sliding contact. It is also called as a sliding contact, which checks across the AB conductor where we get the null point. Then we will move this F sliding contact across this AB wire, along the AB wire. AC represents, here AC is there, AC represents the source of alternating current. So current is not a continuous, it is an alternating source of current we are providing. The sliding contact is moved along a AB, as you can see in the figure, until no current flows. The detector D shows no deflection. If current is not flowing, our detector won't show us any deflection, and the null point is thus obtained at C. So we have to search for the null point according to the Wheatstone bridge. So formula is given. So which across the AB where we are getting that null point, so that length we have to measure. So it will get divided into the AC, length AC and length BC. Okay. So length AC and length BC is what? It is the length obtained when a particular point on the this wire AB we are showing a zero deflection, or we'll call as a null point. So null point here is C is a null point. Now according to the Wheatstone bridge, what is the formula? R of solution, that is the resistance of solution divided by length of AC is equal to, this is a variable resistance of a Wheatstone bridge which is showing Rx divided by length BC. So R of a solution, resistance of a solution which we are not knowing, divided by the length AC, whereas Rx which we are knowing, divided by the length BC. So finally, how you will find out resistance R of a solution? R of a solution is length AC upon length BC into Rx. So here this two value will be given, Rx will be given, only you have to calculate R of a solution. So this is practically when you will perform, you will understand. By measuring the length AC and BC and knowing Rx, the resistance of KCl solution can be easily calculated. The cell constant is given. So now, once you will know value of R, you can find out cell constant. So what is the formula for cell constant? We have seen K is equal to cell constant divided by R. So R value is knowing, value of K is also is given. So when we will multiply K into R, we will get cell constant value. So we can calculate cell constant for a particular solution of an unknown resistance. Now you can also determine the conductivity of a given solution. Yes, you can also determine the conductivity. So how will determine the conductivity? KCl solution in the conductivity cell in step 1 is replaced by the given solution. So KCl solution, which is we have used in step 1 here, that we will replace. Okay, when we will replace by the given solution whose conductivity is to be measured, its resistance is measured by the process described in step 1. The conductivity of a given solution is then calculated. So if I want to find out conductivity, what I'll do, I will replace this solution and then I will place the solution whose conductivity we want to find out. Then its resistance is measured by process of describing step. So we can measure the resistance as it is. You can see here, we will measure its resistance. So when we know the value of R, when we know cell constant value become what? It is a constant. So once you find out cell constant, then you can use that value of cell constant for other concentrate solution of potassium chloride or any other solution which you want to measure. Calculation of molar conductivity. Yes, you can even calculate molar conductivity. Why? Because there is relationship between molar conductivity and what? There is a relationship between molar conductivity and the conductivity. So molar conductivity, lambda and conductivity, they are related to each other by the formula lambda is equal to 1000 K upon C. The value of K will be calculated, concentration will be given, so you can find out molar conductivity. So with this, we have seen how we can use this information and can find out what three things we can find out. First, we'll calculate cell constant. After calculating cell constant, we can able to calculate conductivity of any given solution. And after that, from the conductivity, we will find out molar conductivity. Okay. So student, let's see one problem so you'll understand. Now, a conductivity cell containing 0.01 molar KCl gives at 25 degrees centigrade the resistance of 604 ohm. So here concentration of KCl solution is given, it is 0.01 molar. Temperature, it's the room temperature 25 degrees centigrade around. But the how much conductivity? 604. So this is the value of K, small k is given. Now the same cell is containing 0. Now we will change the solution. We will use 0.01 molar silver nitrate. It gives the resistance. So it giving us resistance R 6530 ohms. So here for the new solution, value of R is provided. Calculate the molar conductivity of unknown solution. What is that unknown solution? Concentration 0.01 molar AgNO3. So how we will solve? See, first we want to know the cell constant. How we will calculate the cell constant? Cell constant is the one which is given, conductivity of KCl, that is 600, and resistance is given R, that is 604, and its conductivity is how much? 0.00141. So resistance R is 604. This is not a small k, this is a resistance. Resistance is mentioned here, and conductivity is small k is 0.00141. So value of K and R given, so cell constant is calculated. And always keep it in mind, unit of cell constant is meter inverse or centimeter inverse, because this ohm rho, this will get cancelled, omega, and it is centimeter inverse. Now we have calculated cell constant. Now we can calculate conductivity of unknown solution. So for AgNO3, so we will write formula K is equal to cell constants upon resistance. Cell constants 0.852 centimeter inverse. R, value of R is given for AgNO3. How much it is? 6530. So that we have written. So value of K for this AgNO3. Value of what? Conductivity we got. Value of K. Now what they are further asking? Molar conductivity. Molar conductivity, lambda is equal to 1000 K upon C. 1000 small k, 1000 into conductivity upon C. So conductivity is 1.3 into 10 raised to minus 4 we have calculated. So that we will multiply to 1000 and divide by its concentration, which is given 0.01. So students, see to it that if known value, this problem may come for 3 marks. It will come in the exam, and this is very easy problem. If anything known is given, you want to find out unknown. So cell constant, you have to find it out. When you will find out cell constant, you will get a 1 mark here, half mark for writing formula, half mark for calculation and correct answer. After that, you will use that cell constant value, and in this formula, K is equal to cell constant divided by R. Here we will write half mark for writing this formula. So formula is very important. And then we will get 1.3 into that for this half mark for writing a proper unit. Then calculation of molar conductivity. Then we will calculate molar conductivity how? By this formula. So this is interdependent. When you will calculate this, you will get this. When you calculate this, you will get the next. Okay. Electrochemical cell. Now we are going to study different types of cells. So electrochemical cell, they are consist of basically what cell consists. Cell consists of 2 electrodes. If it is electrochemical cell, mostly it is contain metal plates or sometimes carbon electrode or graphite. Then electrolytic solution or ionic conductor, we can say, to transfer the or for the flow of ion. Electrolytic solution is needed so that the electrons will form on the redox reaction. or ions will form, ions will get discharged at a respected electrode. So the two types of electrodes are cathode and anode. And the type of reaction which takes place in the electrochemical cell is a redox reaction. One cell oxidation reaction takes place, that is our anode. And the reduction reaction takes place at a cathode. Now, these two cells, oxidation half cell and the other one is reduction half cell. These two cells combine together to give us a complete cell reaction. So we will see this step by step. Even you are aware of all this. You have studied in the 11th also, and few of you are knowing in 10th standard you have studied the cell reaction. So let's go to it. Now electrodes, as I have said, two electrodes are there, cathode and anode. Cathode is a negatively charged, and which reaction takes place at cathode? Reduction. As it is negatively charged, reduction takes place. Reduction is a process where electrons are accepted. Anode is a positively charged electrode. Here electrons are released. So electrons are released means electrons are given out, and a kind of a species which form if sodium chloride is there, the chlorine gas will form. If it is water electrolysis of water, so hydrogen gas will be released that way. Now here at anode, when water is there, oxygen gas will release that way. Now type of electrochemical cell. There are two type of electrochemical cell: electrolytic cell, and other one is galvanic or voltaic. So electrolytic cell, let's see what is it in. In this type of a cell, the type of reaction which takes place are the non-spontaneous one. Non-spontaneous reaction means what? They are continue going on until and unless the reaction mixture will completely, whatever the chemical is present or electrolytic solution is present, completely ions will get completely over in it. So it is a non-spontaneous continuous reaction takes place in the electrolytic cell. And this is how this reaction takes place. We have to pass a direct current. So when we pass a direct current through the electrodes, electrolysis will take place. So we are supplying electrical energy, and on supplying electric energy, chemical reactions are taking place. So it is an conversion of, it's a type of a cell in which electrical energy is getting converted into the chemical energy. The anode of the electrolytic cell is a positive. So keep it in mind, in electrolytic cell, anode is always positive and cathode is negative. So in electrolytic cell, non-spontaneous reaction takes place where direct current is allowed to pass through the circuit. Chemical reaction takes place. It's a redox kind of reaction takes place. And the type of electrodes which are there, cathode and anode, where cathode is a negatively charged and anode is a positively charged. It's called as an electrolytic cell. Now next is galvanic or voltaic cell. In a galvanic cell, another name is voltaic. So don't get confused what you are studying. It is a galvanic and voltaic, both are the same. In exam, either way it may come. Now here the type of reactions are spontaneous. Okay. Spontaneous reaction produces electricity. In this cell, chemical energy is converted into the electrical energy. So here it is reverse of the electrolytic cell, chemical energy into the electrical. The anode of a galvanic cell is a negative. See, anode is negative, but cathode is positive. It is reversed. Anode in the galvanic cell, it is a negative and cathode is a positive. So spontaneous reaction, uncontrolled reactions are taking place. And here reaction takes place till the reaction mixture is there. So here the reaction is getting controlled. Here the reaction is taking place in the spontaneous way. Now in exam question may come, distinguish between the electrolytic and galvanic cell. So you can distinguish. There are around 4 points you can easily get. So here in the first you will get a direct current where you will not here use a direct current. Here a spontaneous chemical reaction produce the electricity. Electricity is get produced by the spontaneous chemical reaction. And that's why chemical energy is getting converted into the electrical. Now, let's see electrolytic cell. What is it? Electrolytic cell consists of a container. Yes, we require some electrolytic cell, and that is nothing else but the container in which we will place an electrolyte. Two electrodes we will immerse in it. One is cathode, other one is anode. As we have seen in electrolytic cell, cathode is a negatively charged, anode is a positively charged. At anode, positive species get oxidized. Yes, anode is a oxidation. Here, oxidation reaction takes place. Oxidation means what? Electron getting removed. So negatively charged species will remove its electron and will get stable, will convert into the molecular form from the ionic form. Whereas these electrons from the anode get pushed towards the from anode and pushed to the cathode. So through the electric circuit, electron which have got released at the anode got transferred from anode to cathode by an external circuit. So where this electron goes, which are got released at anode by the oxidation process, get transferred from anode to cathode. Whereas at cathode, what happens? Cathode species accept those electrons. So when they accept electrons, so the species which move towards the cathode electrode are the positively charged species, because cathode is a negatively charged electrode, but obviously positive species will move towards the cathode. So positively charged species want to get stable, so it will accept electron and it will either deposit it on cathode, form a coating on the cathode, or get entered into the solution that way. Electrolysis of molten NaCl. So let's understand in an electrolytic cell how molten NaCl get undergo electrolysis. Very easy it is, students. You have studied so many times, so we'll do it very fast. What first we needed? We needed a electrolytic cell. We required a electrolytic solution. So electrolyte is fused sodium chloride. Fused means what? A molten kind of. So in that only ion will form. So we will take a fused NaCl, okay, and the kind of electrode which are immersed in it are the, so the two graphite electrodes are there. So in the NaCl fused electrolysis of fused NaCl, we use graphite electrode. One is acting as a cathode, other one is acting as a anode. Anode will have a positively charged and cathode will have a negatively charged, and then both the electrodes are connected by the direct current. Okay. Now here, this is a fused NaCl solution. Okay. What will happen? They are connected by the metallic wire, okay, by the source of direct current, that is battery is there. Now, the carbon electrode connected to the terminal of the battery as an anode and cathode. Just now we have seen. Now let's see what kind of reactions are occurring. Now fused NaCl, it contains which two radicals? NaCl means Na plus and Cl minus. So two ions are Na plus, we will call it as a what? Cation, and Cl minus as a anion, which are freely mobile. So when a potential is applied, so when we will allow this current to flow, what will happen? Then Cl minus species, which are negatively charged, will move towards the positively charged electrode. Cl minus will see moving towards the anode. By moving towards the anode, it will give its electron and will release in the form of a chlorine gas. You can see here. Whereas the electrons which are free will go through this circuit, external circuit, and will come to the cathode, where sodium chloride ions positively charged. So in order to form a stable Na metal ion, what it will do? It will accept those electrons from a fused Na, will get deposit on the graphite electrode, that is cathode. So this reaction, see here, two Cl minus ions releases its two electron. When one Cl minus ion will give one electron, two Cl minus ions will give two electron. That's why you have to balance the equation. Okay. So two Cl minus ions when get release electron, two Cl gas ion will form, and they will combine to form a chlorine molecule. Same way, you can see here. So Cl plus Cl gives you Cl2 gas, and then ultimately what equation we are getting? 2 Cl minus gives Cl2 gas, which is released at anode, and 2 electrons got released. The battery sucks electrons so produced at anode and pushes them into the cathode. We have seen. Now let's see what has happened at the carbon electrode. That also we have seen. At cathode, sodium ion will take electron. Here sodium ion have a positively charged, so it will take one electron at a time. It will form Na. Sodium solid in the liquid it is, then it will get fused on the electrode. here it should be S actually. This L should be removed as a S because it get converted into the metal ion. So S. Net cell reactions. So the net cell reaction is sum of the two electrodes. So when the two electrodes, we will reaction which are taking place at cathode and anode, when we will add this two electrode reaction, what we will get a final 2Na plus 2Cl minus gives 2Na plus chlorine gas is released. Now what results of electrolysis of molten sodium chloride we get? See, what observations are there? This we have seen chemical reaction, but what you are going to observe? Chlorine gas is getting released at anode. Means that there is a color of the chlorine gas is plain green, or sometimes it gives us colorless also. So you will observe plain green color gas at anode. It shows that there is a release of chlorine gas, whereas the molten silvery white sodium is formed at cathode. So on the cathode, there is a deposition of silvery white color sodium metal will get deposit. Decomposition of sodium chloride into the metallic sodium and chlorine is a non-spontaneous, and the electrical energy supplied by the battery forces the reaction to occur. So reaction will go on continuing. Okay. So as per as you connect it to the electric current direct, so this reaction will go on. Okay. Now, when you will stop the flow, the reaction will stop. Let's see electrolysis of aqueous NaCl. So this is, we have seen for the fused earlier, and this is aqueous. So what will be the difference between them? Now, let's see how in aqueous it takes place. So in aqueous, electrolysis of aqueous NaCl can be carried out in the cell used for the electrolysis of molten NaCl using an inert electrode. Same we will use everything. Only here, instead of fused, we have used aqueous sodium chloride. Okay. The water involved in the electrolysis of aqueous NaCl leads to electrode reaction that differ from the electrolysis of molten. So here we have used water. Here we have not used water. Here it is the fused NaCl, molten NaCl, and here we have used NaCl which is dissolved in the water. So as water is there, so we will see a little different reaction than that of a fused NaCl. So student quite alert when in exam question asks, write a electrolysis of aqueous NaCl. So you have to understand aqueous means NaCl is dissolved in water. So the reaction will be differ than that of the fused. So let's see reduction half reaction at cathode. Let's see what is happening at cathode. Two reduction reaction completes. One is reaction of Na plus. So here we will see two reduction reaction. In earlier we saw only one, that is Na ion accepting electron forming Na. But here we will not see this. We will see two reaction. One is what? Na plus accept electron forms Na solid, and the EMF at EMF electrode potential minus 2.71 volt. So at this temperature, at this potential, you can see sodium ions are getting converted into the sodium solid by accepting electron. Whereas other reduction is of a water, because water is also present. So how water will undergo reduction? So water will accept electrons, and when water molecule will accept electron, gas will form, and OH minus ions will remain as a negatively charged radical. Because you know water, H2O, when you will separate ions in H2O, H plus and OH minus. Now H plus ions which will form will accept this electron and they form a hydrogen gas, whereas OH minus ions, they are remain as it is because they are negatively charged. They won't accept electrons, so they will remain as it is. So along with the hydrogen gas at cathode, hydroxyl ions negatively charged will also form, and this is at minus 0.83 volts. So electrode potential at this electrode potential, you will see this reaction is happening. The standard potential like 5.71 for the reduction water is higher than, standard potential for reduction of a water is higher than that of a reduction of a Na plus. So if you will compare, standard reduction potential of water is higher than that of a reduction of a Na plus ions. This implies that water has a much greater tendency to get reduced than Na plus ions. Hence, reaction 2, that is a reduction of a water, is the cathode reaction when the aqueous NaCl is electrolyzed. So as its electrode potential is higher than that of a 2.72. So this is a negative value. So this value is lesser as compared to this because it is more closer to the 0. So as it has a higher electrode potential, this reaction will take place at a than this. So there is a possibility of two reactions to happen. One is formation of Na solid and other one is release of a hydrogen gas, formation of OH minus ion. So as you have seen there, electrode potential, that's why reduction of Na won't take place in the aqueous NaCl, but the formation of reduction of water molecule will take place. So water molecule will undergo reduction. It releases hydrogen gas at cathode, whereas a chlorine molecule undergo oxidation, will accept electron and will form a chlorine gas. Okay, so this is a complete reaction, half cell reaction of a anode and a half cell reaction of a cathode. Now students, see oxidation of a cathode we have seen. Now let's see for anode. As we know, we have seen in the fused NaCl, at anode what happens? Chlorine molecule forms. Let's see its electrode oxidation potential. It's minus 1.36 volt. Whereas water molecule, if they will, instead of chlorine gas forming, instead of that, if water molecule will move towards the anode, then oxygen gas will release. So two possibilities are there. Now, for this, the electrode potential is minus 0.4. So see, minus 0.4, it is very closer to the 0. So what is the possibility? Which reaction will take place? Second reaction will take place than that of a. So let's see, standard electron potential of oxidation water is greater than that of a chloride ions, or a water has a greater tendency to undergo oxidation. It is therefore expected that anode half cell reaction would be the oxidation of water. The experiment have shown, however, that gas produced at anode is chlorine and gas, whereas oxygen never forms, chlorine gas only forms. Why it happens? Because we have seen in redox or at the cathode that hydrogen gas is releases. If we will compare here, it should be oxygen gas should release instead of chlorine, but they have given reason here that instead of oxygen, chlorine gas is only forming. This suggests that anode reaction is the oxidation of Cl minus to Cl2 is of the over voltage, and the discussion of this is beyond the scope of present book. Okay, fine. So exact reason is not given. So keep it in mind. This is a very important electrolysis of aqueous NaCl, because here we are getting little different kind of product forming at both the electrode as it is expected. But at anode, instead of getting oxygen, we are getting chlorine due to the high voltage issue over there in an electrode. But this is not given in the book. Okay. It has been found that experimentally that actual voltage required for electrolysis is greater than that calculated using a standard potential. And this is an additional voltage required is the over potential. Okay, so whatever electrode potential we are supplying, it's not as sufficient. So for that we have to provide an over more potential, and that's why instead of getting oxygen released, chlorine is only getting released. Okay, students. So see overall cell reactions. As we have seen, at anode chlorine is getting released, which is a half cell reaction, but at cathode hydrogen is getting released. And when we will add these two equations, what the final equation we are getting? 2Cl minus plus 2H2O releases chlorine gas, hydrogen gas, and negative hydroxyl ion forms. So very important to understand and practice this reaction. You write it in the book. Only reading and then directly writing in the paper, it's not at all possible. You have to write, you have to check the sign, you have to check the states of the ions, aqueous, solid, liquid, whatever. Okay, student, this is very important. Now, let's see. Now you have seen results which we are getting at both the electrode. We are getting hydrogen gas at cathode. We are getting chlorine at anode. See, because Na plus ions remain unreacted and OH minus ions are formed at cathode, so NaCl solution is converted to the NaOH. See, this is again very important. We have seen OH minus ions get free. So where these OH minus ions go, these OH minus ions will combine with Na plus ions, and what will form? NaOH. So during electrolysis of aqueous NaCl, we get formation of a NaOH. It may come in the MCQ also. When the electrolysis of aqueous NaCl takes place, dash form. So different options. So formation of NaOH is there. Okay. Now let's complete the last part. Quantitative aspects of electrolysis. How? Now see, we have seen the practically how it happens. We have seen the cell reaction. Now quantitative is also again important. How quantitatively we are getting, what value we are getting, how much current we have to supply. Okay, everything. Now the mass of a reactant consumed or the mass of a product formed at an electrode during the electrolysis can be calculated by knowing stoichiometry of a half reaction at the electrode. Yes. So whatever mass of a reactant consumed, means suppose you have taken a particular molar solution. From that molar solution, and any molar solution, when you have to prepare, you have to dissolve certain amount of a substance into that particular amount of water. So how much you have used, how much is getting used up during the reaction, and at the end how much product we are obtaining. So this is called as a quantitative aspect, and this is only possible by the stoichiometric reaction. Means the reaction should be balanced. If you will use unbalanced reaction, you won't get correct answer. Calculation of quantity of electricity passed. So let's see how we will calculate how much electricity is passed during the cell reaction, because we are supplying electricity for the reaction to take place. To calculate the quantity of an electricity Q passed during the electrolysis, the amount of current I passed through the cell is measured. The time for which current is passed is noted. So how long we have allowed this reaction to take place. So I can be calculated by multiplying with T, time. So you can calculate electricity, okay, the amount of electricity passed by this formula, Q is equal to I into T. Now calculation of moles of electron passed. Yes. Now there is a one formula is given. So total charge passed, Q, it is represented by the Coulomb. So total charge passed is Q. The charge of 1 mole of electron is 96,500 Coulomb. So this value you know. For 1 mole of electron, how much Coulomb charge is there? 96,500. Okay, this standard value is with us. It is referred to as 1 Faraday. Yes, 1 Faraday is equal to 96,500 coulombs. Hence, moles of electron actually passed is equal to Q upon that value you have to divide. Means like, see, for 1 coulomb is equal to 96,500. Okay. Then for this much mole of a, and that is for 1 mole. Okay. So if you have passed Q charge of a coulomb, then how much mole of electron will be used up or maybe passed. So this is just a unitary method. From for 1 is this, then for this how much. So cross multiplication is there and the formula is given. So in exam, if question is asked, calculate mole of electron. So you have to simply, whatever coulomb is provided, you divide it by the 96,500. So this value you have to remember. Okay. Calculation of moles of a product form. Okay. Now we have to calculate how much mole of product form. Here we have calculated mole of electron. Now we want to calculate mole of product form. Now for that, balanced chemical equation is important. The balanced equation for half reaction occurring at electrode is devised. The stoichiometry of half reaction indicates the mole of electron passed and moles of product form. Yes. Let's take a reaction like when copper ion accept electrons. Now we know copper ion have a +2 charge. So definitely they will accept 2 electrons. And when they will accept 2 electrons, they will undergo reduction. They will form a copper solid. 2 moles of electrons are required for a production of 1 mole of a copper. 2 moles of electron. Yes. If you want to produce 1 mole of a copper, how much electron have been used here? 2 electrons. So we can calculate the moles of product form. The moles of electrons actually passed are given by the equation C. To simplify further, we introduce an entity mole ratio. So mole ratio is what? Mole of a product formed in the half reaction divided by the mole of an electron required in the half reaction. Now, for a reaction of copper, mole ratio is 1/2. Okay, 1/2, like that, 2 electrons are there. So moles of a product form is 1 mole and number of electron used are 2. That's why 1/2. So we have to just put, in order to calculate mole ratio for copper, we will take number of moles are formed divided by the electrons. So this formula again very interesting and very important and easy also. So 1/2. Therefore, moles of product form is equal to moles of electron actually passed into the mole ratio. In order to find a mole of product form, what is the formula? Moles of electron passed into mole ratio. Now, moles of electron actually passed, that we can calculate it. Just now we have discussed, that is Coulomb, we will divide it by the 96,500 into mole ratio. Mole ratio is also we have calculated, it is half. So this is very easy, students, and very important also. If such problem will come in exam, you have to attempt, you will get here good marks. Okay. Last, calculation of mass of product. Now, quantitatively, how much product form? Very important. So W, that is the weight of a product, is equal to, or mass we can say, mass of a product, which is symbolized with the alphabet W, moles of a product into molar mass of a product. Moles of a product into molar mass of a product. Moles of a product, we will calculate moles of a product this way. Here only we have calculated, and molar mass of a product. So it is a combination of all the formulas, that is, I see here now again, this next step, like Coulomb. Coulomb, if it is not given, instead of Coulomb, means instead of charge, they have given an electric current, ampere value, and time. So you can multiply that two value and you can find value of Q. So you may think, ma'am said Q upon 96,500, but sometime there is a interlink, further calculation is there. So there you have to understand a formula for Q is I into T. So I and T, when you will multiply, you will get Q. So ultimately I into T divided by this 96,500 into the mole ratio into molar mass of a product. So this way we will calculate, and these all are important. You write it down in the book as today I have explained you. Immediately you study it, so you will understand. Have any doubt, you ask me next time. Next part I will take in the next class only, because it won't get complete. And then we will see problem based on this. There are so many problems are there which we will solve. Then after electrolytic cell, we will move towards the galvanic or voltaic cell. So we will study everything about the galvanic and voltaic cell. This is again a very interesting student. Okay. So we will stop here.